Hello everyone. In this video, we are going to determine the inverse function given the restriction, and this is the third part. Let's take this example right here. Determine the inverse of the function given the restriction. So the function is f of x is equal to quantity x plus 3 squared minus 1, where x is greater than or equal to negative 3. Now let's sketch the graph of this function right here. Okay, looking at the equation that we have right here, we can tell that our vertex is located at negative 3, negative 1. Because remember, we are going to switch and keep. So then the vertex is at negative 3, negative 1. So I'm just going to write that down here. Now we are going to determine the equation that we're going to use in order that we can graph this function right here. Okay, so the equation that we're going to use is, we remember the trick is, I already mentioned this trick from the previous parts. We cover the h and we also have to cover the k value, and so whatever is the leftover, that's the equation that we're going to use to complete the table, and that would be y is equal to x is the only leftover because we cover the h and k, and that is squared. So then we go ahead and say that from the vertex, okay, so we are going to plug this 1 and 2 into this equation that we got here. So then we can go ahead and say that this becomes the x, and we plug it in here. So that is the first parentheses, and they are squared. So the first row will have 1. The second row will have 2. So 1 squared is 1, and then 2 squared is 4. Since they are positive, we go up. Okay, so we're ready to sketch this graph right here, which is x plus 3 squared minus 1. So we start from the vertex negative 3, negative 1. So that's going to be on negative 3 down to negative 1. So this is our vertex right here. And it says that from the vertex, we go 1 right, 1 up. So we go 1 right, 1 up. So it's going to be right here. And then 2 right from the vertex, so 2 right, 4 up. So 1, 2, 1, 2, 3, 4. So it's going to go all the way right here. Since this is a quadratic equation, we can therefore say that the shape of the graph is a parabola. So then we go ahead and reflect it across to create the parabola right here. So this is the parabola that we have for this, the shape of the graph for this function that we have right there. Now, looking at this, we can tell that this is not a one-to-one function, because if we are going to pass a horizontal line, if we use the horizontal line test using the pencil, you can see that this graph is actually touching the pencil twice. So it's touching at 2 points on the pencil. That means that this is not a one-to-one function, and so it means that it does not have an inverse function. So that is the reason why we have this restriction right here. We only consider x is greater than or equal to negative 3. So if we say x is greater than or equal to negative 3, so negative 3 on the x, so we only consider the one that is greater or to the right of the negative 3. So this is the branch that we consider. That means we are going to erase this other branch right here. Okay, as you can see here, this is already one-to-one function. That means if we pass a horizontal line on this graph, it only touches the horizontal line one time. So there's only one point that touches the horizontal line each time. So this graph that we have here has already an inverse function, or the function is, the inverse is already a function. So then we can go ahead and say that given this condition that we have right here, again, we restricted it, that is x is greater than or equal to negative 3, we can go ahead and say that the domain for this given graph with this restriction right here is actually x is greater than or equal to negative 3, And then the range for this would be starts from -1. So y is greater than or equal to -1. So this is our graph for f of x. So we're gonna label this as our f of x. Okay, now let's determine the equation of the inverse. So we have some steps to follow in order that we can determine the inverse of a function. So I'm just gonna copy this equation up here. Okay, the first step in order to determine the inverse is to replace f of x with y. So in this case right here, I'm going to change the f of x to y, and that is equal to x plus 3 squared minus 1. Now we're ready to move on to the second step. The second step states that we are supposed to replace every x with y and replace every y with x and solve for y. So this y becomes the x, and that is equal to, this x becomes the y plus 3 squared minus 1. And then again, part of this step is to solve for y. So that we can go ahead and add 1 to both sides, plus 1 and plus 1, so we can cross the 1 out. And so we are left with x plus 1 is equal to y plus 3 squared. Again, we are supposed to solve for y by itself. So the antidote for squared is square root. So we're going to square root both sides. And this will cross out the squared and the square root. Now, we remember that if we square root, there are two solutions, the positive and the negative. So then we go ahead and write plus and minus. So that we can go ahead and rewrite this as... Okay, since we wanted y by itself, we are going to subtract 3 from both sides, minus 3, so that we are left with, we can cross this out, that's plus minus square root of x plus 1, that's a minus 3 is equal to y. Now the problem here is that which of this do we have to pick? Is it the positive or is it the negative? The trick here is that we'll look at the inequality right here. So if the inequality is greater than or equal to, then we pick the positive solution. So we pick the positive. Now if this one was less than, we pick the negative, because we were supposed to do the other side right here. That's this this is for the negative side. So that means since this is greater than, we pick the positive. So that we go ahead and rewrite this as... Okay, and finally, the third step to determine the inverse is to replace the y of the equation solved in the second step with f negative 1 of x. So that we can go ahead and finally say that our inverse is f negative 1 of x, that's the y right there, is equal to, that's going to be the positive solution, and that is equal to x plus 1 minus 3. This is the inverse of this function that we have right here. Now notice that if we have this restriction that we have here is actually answered in our inverse as the positive solution, because that, again, that's greater than. If this was less than, then we would have picked the minus or the negative solution. So that we are now ready to sketch the graph of this inverse. So I'm gonna show the work on this paper right here. Okay, just by looking at this equation that we have right here, our vertex is, remember we switch and keep, so our vertex is located at negative 1, negative 3. So I'm just going to write that down here. Okay, now we are going to determine the equation that we're going to use to complete the table. So I'm just going to write that down here. Okay, again, the trick is that we are supposed to cover the h, that's 1 right there, and we cover the k, and then whatever's the left over, that's the equation that we're going to use in order that we can complete the table. So the equation that we are left with is y is equal to the square root of x. So that from the vertex, Okay, so we're going to plug this 1 and 2 into this x right here. So the work that we're going to have would be on the side. Okay, so we are going to determine the square root of this. So the square root of 1 is just 1. And then the square root of 2 is approximately 1.4. That means they both go up from the vertex. So then we can go ahead and say that we start from the vertex, -1, -3. So that is -1. We go down -3 right here. So this is our vertex. We say that from the vertex, we go 1 right, 1 up. So I go 1 right, 1 up. So it's going to be right here. And then after that, so from the vertex, we go 2 right, 1.4 up. So this is going to be from the vertex 1, 2, and then 1.4 up. So it should be somewhere around here. So then we can go ahead and say that we can sketch the graph of this square root function like this. Okay, so we go ahead and determine the domain for this graph. We can tell that our domain is x is greater than or equal to -1. And then the range for this graph that we have here is y is greater than or equal to -3. So let's change the color for this graph right here. Okay, so this is the graph of the function that is the restricted function, and this is the graph of the inverse function. Okay, as you can see here that these two graphs are actually symmetric with respect to the line of symmetry, which is y is equal to x. So if we are going to draw that line of symmetry right here, and if we fold it through that line, it's gonna match up. So looking at this graph, we can tell that this function that we have here and this function that we have here are actually inverse of each other. Because if we fold it across the line of symmetry, y is equal to x. If we fold it this way, this two red and blue graph will match up. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!